Welcome to another video on my Raspberry Pi 1 running Raspbian Linux, connected to serial interface for data acquisition, oscilloscope for signal display, Raspberry Pi camera, RaspberryCam for alternative view of camera, and network for VNC, virtual network computing, connected via band cable to breadboard. This circuit, light dependent resistor from fischertechnik, and you also noticed the fischertechnik stand for the RaspberryCam, ordinary light dependent resistor and an NTC, and an ordinary resistor. MCP 3008 analog to digital converter using the serial peripheral interface protocol for data transfer. Also using MacBook for showing the VLC display of the RaspberryCam, as well as Pi scope, which shows internal display of signals, and that doesn't come easy with my Android. I hope this works out. Yes, it works out, although not very clearly, so I should cover some light. Anyway, the idea is that with Python I run a program to read the values, and then with Octave, scientific language, I put them in a datalog. All nice, but I get the wrong values. I want ASCII in the datalog and I get bytes. Last time I made some progress, but unfortunately not enough. So that is where I want to go. And also an LED that shows whenever one LDR is over a value of 100. So let's see how things work out this time. And first of all, I am going to run the coder, and here you can see that the LEDs are blinking, so that's plus. And now onto the software. And a very short recap. This is the output to of the video, the VLC stream. So no PiCam or no Pi scope on here. Screen output. And everything is slowly right now because there are running many processes also on the other VLC screens which are on the Android and on the Mac right now. So this is alternative. This is normal cam, and this you also see on the Mac. On the Android, unfortunately, it doesn't want to pick up the stream. So I have to do it with this one. Then Octave, and I have to click here. Octave, a nice algorithm which picks up from serial interface and detects difference in LDR1, LDR2, NTC and resistor. All nice, except that this is not readable. These are bytes and not what I want, like these values. I want to see these values in here. So that is what I will focus in here. So that's what I will focus on. What did I do last time? I tried in the same way as I did try earlier, right here. How can I put bytes into ASCII? All nice, and this seemed to be the way. And now I have to go to the Minicom and quit it, otherwise I don't have, because this is what I use to see if everything is working. This is nicely done, and this is what I want to see in the data log. Well, you can clearly see that is not the case. So here everything is displayed nicely, and here it's in bytes. Oops. So right now I quit Minicom and I will start Octave, expecting the same thing as now, but who knows whatever goes wrong. Another thing that I had to do was change this into this. This went well because it's in it is the 17th element in the first row and not the first element in the 17th row. Anyway, that's how things work out. Although here you have the opposite way. So this says, okay, it is character 17, row 1. So why would this be different? And yet that turned out to work. Strange things. Okay, I have one other thing to do probably, and that is claim ownership, but let's just run it. And that's what I mean. I have to claim ownership of the USB port. So this is tab USB and from dev TTY USB 1. That's done. So go, and now it does work. And you see here it captures all nice values. Everything is normal. So I'm going to go in here to the end. And it doesn't do a thing now. So and that's confusing. One time it seems to not matter that I look at the content of datalog real time, and other times I have to quit looking at it, stop the program and then look at it. Not quite sure why that is. Right now it has nothing in it, so I am quitting the program. And here we are, same stuff. So I have to take a look at that. Why is this working for first thing and then not? because LDR1 okay, look at this. LDR1 says 1. Is LDR1 1? Not really now. ASCII is 1. So this is byte and this is ASCII, and that is correct. So maybe I should do exactly the same for the other things, although I think I already did. I just didn't print it. Anyway, let's see. Right, another thing to do is what I want to try is not just one but the first 3 bytes ASCII characters, and I just hope that this is right. I didn't test it yet. Let's go. And that seems to work out. Here 48. Look here. This doesn't seem right. LDR1 is 1 N. Here I know that it is the first thing to do. This is 17.1, this is 17.123. But this is rubbish. It doesn't exit. It doesn't go wrong, but what I see is rubbish. So how can I change this? I want to see nice ASCII characters after another, or under each other. I don't mind. 17, 18 and 19. This as well. So what is 17.1 ASCII doing? It gives 1. Theoretically that it can be correct. If it is 1. If there are spaces and it is 1. So theoretically, yes, that can be correct. Let's view it again. Running it for a while. There we go again, data 2, yes. Okay, let's quit this now. Go up, and here we are. So why is an LDR value 247? It doesn't really make sense. Or I should do it in another way. Not like this anyway, because that I should give it not 1, 2, 3, but 3 different lines, and that may be wrong or difficult to read. So that would be something in the line like this. Not 1 but 2, not this one. This one goes away, and this one goes away, and then just like this. And then last one, this one, and this will be 3. That should be better readable. Question is it? I'm absolutely not certain of it, but let's go. This is old. This is okay. I saw a new version of it. Let's quit. One, 2, 3. 1 is nothing. 2 is 10. 3 is nothing. So with this quit, take a look at the can I make some sense out of this? LDR only, LDR1 only, 10, this should be 10, but 52 is 2 that I know of. So where do I go wrong? Why can't I just get the values that are displayed online nicely? Because this is what I want to see. Why can't I get them in the data file? Seems to be so easy, except that it isn't. Maybe I'm looking the wrong way. Okay, let's just move out this one. So this is displayed nicely. Although it makes no sense. Let's get rid of this one, these lines as well, to make it nicely readable. And for the register I didn't even do it. Okay. Let's go again. Those are the values I want to see. LDR2, 47, yeah, 56, and let's just change the value for whatever reason. Okay, enough testing. That should be it. Nice values, and I don't have much hopes. No, none at all. So if everything is displayed here nicely, LDR1, LDR2, NTC 7, and that's the first character, first byte. value 247 data 2, and that's all this. Data 2 is displayed nicely. So why can't this be displayed nicely? I am doing something wrong, but what? And by the way, oscilloscope shows this. Once again, let me get rid of the light. So all signals are here clear, and on the oscilloscope, real stuff, only the RS232 signals are displayed nicely. Okay, I have to turn them the other way. I'm back at 1 millisecond, but SPI, which are these lines, these 3 lines, are displaying nothing. And yet, when you take a look at the Pi scope, you can clearly see right here they are there. Closer look. And I know the lighting is not good, but at least it's there. So how can I fix this? And then, as you can see, I found a solution, which was in a very different way than I expected. It didn't matter if I put all the data in, like I do still here. It doesn't matter if I put character or whatever. No, it doesn't matter. What does matter is this. As long as I put a D in it, because I thought those are digits, ASCII, but no, it's a character. And if you put the character in it, it displays as ASCII. So I am putting this to the test and removing this stuff, because it has been proven to me that this just works. This is going away, saves a lot of code, and this has to be changed into character. This hasn't been changed at all even, so this has to be changed to character. And there's one difference still, that this is character and this is just the way it was. So I am changing this, and let's now see how the data log will be filled. Because those details may still matter. And there we go with, yes, very good, all of them, and off running. Now the data log. Well, not everything has been set, but at least I have them all in here. It's NTC LDR. So why not the other ones? Because I have seen those too. And it's clearly NTC and LDR only. Only this and this one. It doesn't. It's all the same now. So yeah, I think this is just it, which is nice. And if I now let it run for some longer time, it's all good. So that's nice. Now let's take a look at results on the Mac as well, although they won't be very different. Alright, and then on the Mac you see here the Pi scope, which shows the signals but not in the right time scale. This is just timing. And serial is working, SPI is working, but not quite the way I expect it to be. And of course VLC is working quite nicely with the streaming video, although with some delay. And I would like to do Octave stuff here as well, but this is an older Mac by now, and I'm not sure Octave for this version is still supported in what way, whatever. Talking about Pi scope, it's slow, but I was surprised that I could run it anyway on in 3 instances on 3 VNC viewers, because I have one here on the Mac, one on the Android tablet, and one on Fedora Linux. Anyway, possibilities left over. Oh shit. One little note on my Android tablet. The problem is that I have to record it this way. I tried to make a screen recording like I do on the Linux laptop and with the Mac, but that software doesn't work. So unfortunately I have to do it this way. Maybe I can do screen captures, but recordings, that's another thing. Anyway, I'm glad that I solved this one, at least partially, because LDR2 and resistor are missing. But this is working and the rest now as well. And with that I say thank you for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, always appreciated. I do hope next time I can get the oscilloscope camera to work. But this works and the rest works as well now, also much better with Octave. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion. You can also follow me via Instagram and Twitter. Please consider a donation to show your support. Donation can via PayPal and Wired, and you can also become a patron, and depending on the pledge you make, may have your name mentioned. Going to be continued. Have a nice day and bye bye.